my answer. Any questions on this? Okay, number 2. Okay. I want you guys to look at this right here. I gave you the 5 ways to solve quadratic equations. By raise of hand, who thinks they know the best way to solve this one? I mean, you know what? The best way is whatever way is easiest for you to solve it. But what do you guys think right here might be the best way, by raise of hand, to solve this one? I'm going to call on Dean first. The quadratic formula. What do you think? Factoring. Any other ideas? I think it needs to be one of those 2 methods. Okay? Or Gabe, you ready? I think it needs to be one of those 2 methods. You guys, if you know how to factor, this is fastest to be done by factoring. Got it? If you don't know how to factor, then I would use the quadratic formula. All of them can be done using the quadratic formula. But are there 2 numbers you can times together and get negative 40 and add together and get 3? 8 and negative 5. You guys, 8 times negative 5 equals negative 40. And 8 plus a negative 5 equals 3, which is the middle term, right? You guys see that? So we could write this as x plus 8 and x minus 5 equals 0. And we want to know what number I can put in for x and add 8 and get 0. Negative 8. So x equals negative 8 because negative 8 plus 8 would be 0, and 0 times this would be 0, so that would make it true. How about for this one? If I put 5 in there, 5 minus 5 is 0. So my 2 answers are negative 8 and positive 5. So that one's probably best done by factoring. Okay? So I think that one's best done by factoring. Okay, choose another one. Number 8. You guys, I'm not going to do both number 3 and 8. I'm going to say this about number 3. That one is factorable. But notice that number 3 has a 2 in front of it. I could do it fastest by factoring myself, but if you guys aren't as versed in factoring as I am, so it might be easiest for you to do it by the quadratic formula. Okay? I would say 5 and 8, I'm betting both of those have imaginary solutions. What's the only way to solve it if it has imaginary solutions? Quadratic formula. You could do completing the square, but we don't know that method very well.
What is that one?
Okay, I'll do 5 or 8. I won't do both of them. Which one do you want to do?
Do 8. Like 8.
Okay, 8. Yeah, the quadratic formula. Like I'm going to do number 8 right now. Okay, number 8 is 4x squared plus 3x plus 1 equals 0. Yeah, we're going to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Some of you guys are forgetting that. What's that all called? Everybody say, what is that called? Quadratic formula. Okay, Gabe, what's a, b, and c in this one? 4. 1 is the c. And I'm gonna plug these in here. Negative b. The opposite of b would be negative 3. Opposite of b, right? Plus or minus the square root of. We haven't figured out the discriminant yet. Should we do that really quickly up here? B squared. That would be 9. 3 times 3 is 9. Minus 4 times 4 times 1. I know 4 times 4 times 1 is 16. 9 minus 16 is negative 7. So I know that the discriminant is negative 7 divided by 2a. 2 times 4 is 8. Now, you guys, 7 is a prime number, isn't it? So there's nothing I can do to simplify that, but I can rewrite it without being the square root of a negative number. What can I rewrite this as? Negative 3 plus or minus what? I square root of 7 all over 8. That's it. And there's there is the answer for number 8. What was that? Imaginary solution. So the only way we know how to do this one is quadratic formula. Lacey. You can do the quadratic formula to all of them if you want to. But let me say this, Lacey. See number 1 and number 6? The fastest way to do that one is to get x by itself because there's no linear term on those two. Yeah. Okay. No, you only put an I when the square root is negative.
Oh, so you just turned it into a positive.
Yeah, well, we learned that I equals the square root of negative 1. Do you remember doing that the first of the year? And the square root of negative 7 is the square root of negative 1 times the square root of 7. You can rewrite it like that. And so we just replace the square root of negative 1 with I right here. And then you had 7 as prime, so it doesn't simplify, so we just leave it as square root 7. You have to turn, anytime you have a negative inside the square root, you have to turn it into an I. Yeah, and if you get a positive, if the number doesn't, I mean, you never have an I if it's positive. But the number inside might simplify. Remember how we've been breaking them down? Stephanie. Did you guys hear that? What Stephanie said? Stephanie said if there's a negative inside the square root, just put an I on the outside. That's all you have to do, and don't write the negative anymore. That's what you do. Okay. I'll do one more before we correct it, Shania. Number 4. Okay, guess what? Number 4 can be factored. However, look how big those numbers are. Even I, knowing factoring really well, would probably rather use the quadratic formula on this one. Okay? So, because for one thing, we don't know. Even I would use a quadratic formula. So what's A, B, and C on this one?
15,
Okay. So x equals the opposite of b. What's the opposite of b going to be? Positive 15? Plus or minus the square root? B squared minus 4ac. Let's find out b squared minus 4ac is. So 15, negative 15 squared, right? But we got to put in parentheses. Minus 4 times 15 times negative 90. We'll definitely need a calculator for that one. I can't do that one in my head. What? It's 5,625? All over 2a. 2 times 15 is 30, right? Everybody put 5,625 and take the square root of it. What do you get? 75? Does everybody agree with that? Everybody agree that 5,625 is the square root of it? It's a perfect square. So it's 75. Okay, let me ask you guys this. What is 15 plus 75? 90. What's 90 divided by 30? 3. So one of my answers is 3. What's 15 minus 75? Negative 60. Divided by 30 is what? Negative 2. So there's my other answer. Okay? All right. That is enough. We are going to correct the assignment now. So, okay, for these kind right here, you guys, you can only solve these in 2 ways. You can solve them by graphing or by substitution. What up, I didn't spell that right. Substitution. Wow. Okay, you can solve these by graphing or substitution. That's it. So that's what we're going to learn. Is everybody ready? All right, everybody, get out your calculator and hit y equals and clear those two things out. Everybody needs a calculator right now. I'm not going to wait for you. Just get your calculator. Dean, get your calculator. Pick up your calculator. Hit your y equals button. Clear everything out. Everybody got that far? Okay, now everybody hit the zoom button right here. And the sixth one down says standard. Hit 6. And that's going to make everybody's window exactly the same. So we don't have to worry about it. So everybody has that? Okay. Now, we're going to solve this by graphing. So everybody hit your y equals again. Oh, by the way, hit your window first. Now, everybody should have a window that says x min negative 10, x max positive 10, x scale 1, y min negative 10, y max 10, and y scale 1. That's what it should. If you hit zoom 6, that's what your window should say now. Okay? Now, hit y equals. We're going to type in y equals x squared minus 5x minus 6. We already have the y equals. So hit x, which is this button right here, squared, which is this button right here, minus, which is this button right here, 5x. There's some people who have never graphed before. Minus 6. Okay? Got it? Hit enter. Now type in 2x plus 2. 2. The x button's right here again, you guys. Plus 2. Okay, now since we already hit zoom 6, we all have the same window. Everybody hit graph. We have a parabola and a line. Now, what is it we're looking for to find a solution here? Where they intersect. How many times do these two things, look at the graph, how many times do these two things intersect? Twice. We can see one of them right here, right? How do you find the other one? Well, the other one we can see is going to intersect up here, right? Somewhere. What we're going to need to do is change our window. We're going to have to go up higher. How do you go up higher on your window, you guys? Window. Which one of these things? The x min, x max, y min, or y max you think we need to change? Y max, because the y-axis goes up and down, right? So everybody go down to your y max. Let's change it to 20. Yeah, the y-axis goes up and down. And change your y scale to 2. The scale tells how often it puts a tick mark. If I put one it was every 1 right there. If I put one every 1, they're going to be really bunched up because we just made the scale. I mean, we went up higher. Hit the graph now. Yeah, here's the x scale. See these little tick marks? If I would have left at 1, there would have been 1 in between every one of those, and that's too many on this screen. Does that make sense? So each one of those counts as 2. Now, you guys, now we see both places they intersect, right? Now, this calculator has a special feature on it that allows you to find where two equations intersect. It's under the calc menu. Everybody find the calc menu on there. Where is it? It's at the top. See the trace button? Look above it. What does it say? Calc. That's the calc menu. Everybody hit second and trace. That brings up the calculate menu. They abbreviate it as calc. Which one of those on there do you think we want? Number 5, intersect. So everybody hit number 5. Okay, now it has this thing that says first curve with a question mark, and it has your cursor is flashing. Everybody see that? What we want to do is move the cursor using the left and right. See these left and right keys? Those are the only ones you want to move on here. Don't hit the up and down keys because all they do is make you go back and forth between the two equations. Okay, so I want to hit the left key until my cursor is about where they intersect. Whoops, I went too far. I don't know what happened. I hit too many times. For some reason, my calculator freaked out and took it clear over there. It won't land right on it, you guys. It won't. Just get close to it and hit enter. And then ask for a second curve guess. It should be close enough, just hit enter again. And then ask for an overall guess, just hit enter a third time. Just get it close to where they intersect and hit enter 3 times. You should get -1, 0. Do you see that? Everybody write that down. These intersect at -1, 0. Got it? Okay, now we got to find the other place of intersection. So I got to do this whole process again. Everybody hit what? Second and trace again. Which one of these do we want? Number 5 intersect. Hit 5. Now you're going to hit your right arrow key until you get to the point where they intersect. Hit enter 3 times. It won't get right on it. No, it's not. I'm just sitting right by it. I can see it. It's not right on it. It just looks like it from you. From your guys are. Okay, where do they intersect, you guys? 8 and 18. Do you get that? That's how you figure out where they intersect my graph. Now, I want you guys to look right here. If I put, there's 2 different answers that work. If I put -1 in for x on this equation and 0 in for y, I would get 0 equals, and -1 squared is +1, and -5 times 1 is a +5, and 1 plus 5 is 6, and 6 minus 6 is 0. So I get 0 equals 0. Makes that one true, and if I put it in over here, 0 in for y, and x equals -1, 2 times -1 is -2, -2 plus 2 is 0, so I would get 0 equals 0 over here. So -1 and 0 will make both equations true at the same time. Do you see that? Also, 8 and 18 will do it too. If I put 8 in for x and 18 in for y, it would make both sides equal on both equations. Well, no, both of them. I want all the solutions. That's it. So do you guys get that?
Yes, sir.
Okay, that's my 2 solutions. Yeah, you put the 0 in for, yeah, this is the x coordinate, this is the y coordinate. So you put the x coordinate in for x, the y coordinate in for y. Huh? Yep. Yeah. Well, part of it's going to be doing that, and the other part is going to be doing this by substitution. Okay, now, look, you guys. What we're going to do now is I'm going to teach you guys how to do it by substitution. So I need you to tell me what those 2 equations are. Y equals x squared. Is it 5x minus 6? What's the other one? Y equals 2x plus 2. Okay, everybody got those? Now ready. This is substitution. Some of you guys don't understand because you're not listening. Some of you guys are talking the whole time I'm up here teaching. Please listen. Okay, this will be on the test on Wednesday. Now, that was the last method we learned was graphing, solving by graphing. This method is substitution. Okay? Are you ready for substitution method? You got to write it down and listen. Some of you guys are goofing around. I'd sit up and write it down and listen. Okay, here we go. What I want to do is I want to substitute. I want to solve for either y or x in these and substitute them. Look, both of them are already solved for y, right? So I can put 2x plus 2, since y is equal to 2x plus 2, I can put 2x plus 2 in for this y over here. Or I could do it the other way around. But you know what? No matter what, it's going to be the same thing, so it doesn't matter. So we're going to do this. I'm going to put 2x plus 2 in for y, and I'm going to get 2x plus 2 equals x squared minus 5x minus 6. Look, y equals 2x plus 2, right? And y equals x squared minus 5x minus 6. If you have this thing equal to the thing in the middle, and this thing over here is equal to the thing in the middle, aren't the 2 on the things on the end equal? It doesn't. If A equals B and B equals C, what else equals each other? A equals C. Do you understand that? And that's what we're saying. Yeah, we substitute 2x plus 2 in for y because 2x plus 2 is equal to y in the first one. Okay, now, what kind of equation is this, you guys? It's quadratic, isn't it? All I have to, and to solve this, what do I have to do? I got to get everything on one side. I'm going to minus 2x from both sides, and I'm going to minus 2 from both sides. And I'm going to get 0 equals x squared minus 7x minus 8. Now, do you guys recognize that as quadratic? You can solve this in a couple different ways. This one's factorable. Or you can use the quadratic formula. But this one's a really easy factorable one. I want you guys to think about it. What two numbers can I times together and get negative 8 and add together and get negative 7? 8 and negative 1. No, negative 8, positive 1. Look, negative 8 times 1 is a negative 8, and negative 8 plus 1 is a negative 7, right? And that's what I have, negative 8 and negative 7. Do you see that? So, right here, this is going to fact be 0 equals x minus 8 times x plus 1. Okay? And x is equal to 8, and x equals negative 1, therefore. So those are my two solutions. 8 and negative 1. Now that's what x equals. That doesn't tell me what y equals, does it? So it doesn't matter. And I want you guys to go back and look at the solution that we just did. We just did this problem. Notice our answers were negative 1, 0, and 8, 18. Well, just think. Negative 1 and 8 are the two solutions I just came up with. They were the x numbers, right? So to find the y numbers, I've got to put 8 back into one of these two equations and negative 1 back into one of these two equations. It doesn't matter which equations we do. Which one's the easier equation up here? 2x plus 2. So I'm going to substitute 8 in for x in 2x plus 2. So if I go 2 times 8 plus 2, what do I get? 18. And so one of my answers is 8, 18. Because when I put 8 in up there, y becomes 18. We got to use both of them. We got to find both solutions. Now if I put negative 1 in there, 2 times negative 1 is negative 2. Negative 2 plus 2 is 0. So my other solution is negative 1, 0. That's the same two answers we got back here when we did this problem. See? Negative 1, 0 and 8, 18. We just did it by a substitution method this time. You can plug it into both, either one of them. But the reason we did this one is because 2x plus 2 is a simpler equation than that one. It doesn't matter which one you plug them into. That's how you do an algebraic method. Okay, so now you guys know how to do a graphing and an algebraic. I'm going to give you an example right here now. Are we ready? I'm going to have you guys do this by graphing. Here's your two equations. Y equals x squared minus 2x minus 5 equals, that's one equation. The other one is y equals x plus 3. Those are your two equations. I'm going to give you guys a couple minutes to see if you can solve this by graphing. Go. Okay, if I put these in my calculator, I get x squared minus 2x minus 5, and I get x plus 3. And I'm going to hit zoom 6, because I'm going to hit zoom 6 for my standard window again, just see if I need to change my window. I don't even need to change my window, do I? I hit zoom 6 to get standard window again. So if you didn't hit zoom 6, your graph might look slightly different than mine, right, Anthony? So now I hit second and trace. I go to number 5, intersect. My cursor's right down there at the bottom. I'm going to bring it up here where the... I don't know. Because because it's asking for your first curve. Where does your first curve? You hit your second curve and you just get close and you hit enter. Then it asks for a second curve. And then you hit enter. And then it asks for an overall guess. Yeah, it's just trying to get it closer and closer. So they get negative 1.7. I'm going to say it's negative 1.7. Negative 1.7 comma 1.3. I could put 2.9, but the 8 rounds the 9 up, which makes it 1.3, okay? All right, so that's one answer. Now I hit second and calc again. And I go to the next place where they intersect.
Ow, why? Please don't touch me.
You can hold yours down. Mine doesn't do that. Whoops, I went too far. Okay. Now, you guys, mine's a calculator-based. My calculator is computer-based, whereas yours is just a calculator, so you guys can go a little bit faster than me. Okay, hit first curve guess, second curve guess, third curve guess, and I get 4.7 comma 7.7. Okay, is that what you guys got?
Yeah.
When you did it? Can you do that?
Yes.
Okay, that's the answer. Okay, that's the graphing method. Let me do substitution one more time. Okay, if I do substitution, okay, I'm going to rewrite it again. Y equals, what is it again? Y equals x squared. What is it? Minus 2x minus 5. And the other one is y equals x plus 3. Okay. Here we go. They're both equal to y, so I can just set them equal to each other. Right? And they're quadratic, so I'm going to minus x from both sides, minus 3 from both sides. And I'm going to get 0 equals x squared minus 3x minus 8. You got that? And this is a quadratic. This one right here, I'm going to use the quadratic formula. It's not factorable. So b squared would be 9 minus 4 times 1 times negative 8 would be a negative 32. 9 plus 32 is 41. Okay, so there's my discriminant. So I'm going to get x equals negative b, which would be 3, plus or minus the square root of 41, all over 2 times 1, which is 2. Now, everybody take your calculator. Everybody break out your calculator. Go 3 plus the square root of 41 and hit enter. 3 plus the square root of 41 and hit enter. 3 plus the square root of 41, hit enter. And then square root, yeah, square root is you hit second and the x squared button. And then hit divided by 2. Just hit divided by 2. 4.7. Okay, now go like this. 3 minus the square root of 41. Hit enter. And then to go divided by 2. 3 minus the square root of 41. Hit enter. And then go divided by 2. What'd you get when you did that one? Negative 1 point what? 7. Now, I want you guys to look back at our other answers. Let's go back to their answers. Those are the x values of both answers. Negative 1.7 and 4.7. Do you see that? Okay, so how do you get the y answers? How do you get the y answers? Plug this into one of these equations. Which one's easier? That one, right? What's 4.7 plus 3? 7.7. So 4.7 comma 7.7 is one of my answers. And what's negative 1.7 plus 3? I believe it's 1.3, isn't it? So negative 1.7 comma 1.3. Is that what we got on the other ones? Let's check. Yeah, negative 1.7 comma 1.3 and 4.7 comma 7.7. There's our answers. So that's the algebraic method right there of doing that. Okay? Yeah.
Why did you divide by 8?
2 times a. A is 1. 2 times. Okay? All right, your assignment, you guys, I got an assignment right here for you.